Arger, there is a civilization that built cities in the jungle, mapped the stars with terrifying precision, and then left behind a mystery their own descendants are still living inside. Built for for centuries, we thought we knew where the Maya came from. Then their DNA started speaking, and not all of it agreed with the story we'd been telling. Definitional. The official narrative was simple enough to fit in a textbook. The ancestors of the Maya arrived in the Americas via the Bering Land Bridge, moved south over thousands of years, settled in Mesoamerica, and gradually developed the language, agriculture, and ceremonial complexity that would become classic Maya civilization. Linguists traced Mayan languages back to a common root. Archaeologists found a steady cultural crescent from early farming villages to the towering pyramids of Tikal and Palenque. It looked like a closed loop. One people, one homeland, one long, unbroken thread. But threads, it turns out, are rarely that clean. The first cracks appeared in places nobody expected, not in the temples, but in the teeth and bones of ordinary people buried beneath them. Isotope analysis on skeletal remains from sites across the Yucatan and Guatemala began showing something odd. Some individuals weren't born where they were buried. Else, their childhood diets, locked into their bones through chemical signatures, pointed to origins hundreds of kilometers away. That alone wasn't shocking people moved. But the patterns were inconsistent with the simple linear settlement story. Something about the population's formation looked less like a single migration and more like layers, stacked one on top of another over a much longer time scale than anyone had assumed. Then came the genome. When researchers began sequencing ancient DNA from sites across Mesoamerica, extracting genetic material from remains, sometimes thousands of years old, they weren't just looking at where people came from. They were looking at deep time. Ancient DNA works like a kind of biological archive, preserving signals from population movements that happened long before anyone wrote anything down. Autosomal DNA, inherited from both parents, could reveal broad ancestry mixtures. Mitochondrial DNA, passed only through the maternal line, could trace deep female lineages stretching back tens of thousands of years. And when these tools were pointed at the genetic history of the Maya region, Elsaya, the results didn't simply confirm the old migration model, they complicated it. If you're drawn to stories where the evidence quietly rewrites the map, this is a good moment to subscribe, because what comes next is where things get strange. What the genomic data revealed first was that the ancestors of Mesoamerican populations, including those who would become the Maya, that carried genetic signatures linking them to some of the earliest populations to enter the Americas, branching off from ancestral North and South American lineages in patterns that suggested multiple waves. Well, not one. That alone wasn't entirely new to specialists, but then came something else. Traces of deep ancestral diversity that didn't match a simple north to south funnel. Some ancient genomes from the region carried affinities that pointed toward populations associated with much earlier, almost ghost-like migration pulses, lineages that seem to have entered the continent early, diversified, and then largely vanished from later populations. Except for faint echoes preserved in specific regional genomes. That was not a contradiction, it was a signal. The story did not collapse, it widened. At what had looked like a single origin point was beginning to resemble something closer to a delta, multiple streams converging, separating, and converging again over thousands of years. Long before the first stone of any pyramid was laid, at this point, researchers found themselves with at least two or three plausible frameworks, goals, and none of them could be dismissed outright. One possibility: the region experienced multiple distinct migration waves from North America over a long period, Bayer, with later arrivals partially but not completely replacing or mixing with earlier populations. Under this model, the deep ancestral diversity seen in some ancient genomes represents the genetic remnants of those earlier arrivals, diluted but not erased. A second possibility: rather than discrete waves, there was a long period of relative isolation, followed by renewed contact and gene flow between regional groups, meaning the Maya as a genetic population were never a single lineage moving together, but the product of long-term mixing between groups that had been separated for millennia and then reconnected. A third, more provocative possibility involves what some researchers describe as a kind of ghost population signal genetic ancestry detected in the data that doesn't correspond cleanly to any known sampled group. Built ancient or modern, its presence is inferred statistically, like a shadow cast by something that isn't directly visible. If such a signal is real, it would suggest that an unsampled or now vanished population contributed to the ancestry of people in the region in ways current models don't fully capture. Researchers remain cautious here. The data doesn't prove which of these scenarios is correct, and it's possible elements of all three played a role. Yes, but each one, on its own, was enough to unsettle the tidy single migration narrative that had dominated for decades. Then came the study that changed the tone of the conversation entirely. Large-scale genomic surveys, drawing on both ancient remains and modern indigenous populations across the Americas, using whole genome sequencing and broad comparative panels spanning North, Central, and South America, allowed researchers to place Mesoamerican genetic history within a much larger continental context for the first time. This wasn't a handful of samples from one site. This was population scale data compared across thousands of kilometers and thousands of years. And what it showed was that the genetic ancestry of populations in the Maya region carried signals connecting them not just to nearby Mesoamerican groups, but to ancient populations from far to the south, deep South America, in ways that didn't fit a simple north to south settlement timeline. At the same time, and certain ancient individuals from the region showed genetic affinities that diverged sharply from later populations living in the exact same place. That's suggesting that the people living in parts of the Maya world thousands of years ago were not the direct, unbroken ancestors of those who built the great classic period cities. Something or someone came after them or alongside them. The data doesn't settle which, not the pattern researchers expected, not even the direction they expected. The surprise wasn't simply that there had been mixing. Mixing is the norm in human history, almost everywhere. The surprise was the geography of it. Genetic threads connecting the Maya lowlands to populations far to the south, and ancient genomes in the region that seem almost like genetic strangers compared to the people who came after them. The genome wasn't erasing the old story of Maya origins. It was revealing an older, stranger one underneath it, one involving population turnover, long-distance connection, and possibly the quiet disappearance of an earlier group whose genetic legacy survives now only as a faint statistical echo in the DNA of their successors. This matters far beyond one civilization in one jungle. For most of the 20th century, the story of human population history was often told as a series of clean lines. Group A came from Group B. settled in place C, and became people D. Ancient DNA has been steadily dismantling that framework everywhere it's been applied, not just in Mesoamerica. Populations turn out to be the product of repeated encounters. Migrations that overlap, populations that mix and then separate again. Mancher, groups that seem to vanish genetically while their cultural practices persist, carried forward by people who are only partly their descendants. And identity, it turns out, is rarely a single thread. It's a weave, and sometimes the weave includes strands from sources we can no longer directly observe or only infer. For the Maya specifically, this doesn't diminish what their ancestors built. If anything, it deepens it. Maneros, the civilization that rose in the lowlands of the Yucatan, wasn't simply the natural unfolding of one people's destiny along a single migratory path. Eventual, it may have been the product of a much longer, messier convergence, different lineages meeting, mixing, and eventually producing the cultural and genetic populations who raised the temples at Tikal. Merkabel charted the movements of Venus and developed one of the most sophisticated writing systems in the ancient world. Picture the landscape itself for a moment, the limestone plateau of the Yucatan, where rivers vanish underground into cenotes, deep natural sinkholes that the ancient Maya considered sacred, portals to the underworld. Dense canopy stretching for hundreds of kilometers, hiding cities that were only rediscovered by satellite imaging in recent years. Boundary, their stone foundations swallowed by root systems and centuries of silence. Somewhere beneath that canopy, in soil that has absorbed the bones of countless generations, then lies the physical record of population histories more tangled than any of the people living there could have known. The descendants of those builders are still there in Yucatan, in Chiapas, in the highlands of Guatemala, carrying genomes that are quite literally living archives of encounters that occurred long before writing, but long before the first carved stela, long before anyone thought to ask where they came from. Sure. If this kind of story, where the evidence doesn't just confirm history but quietly rewrites parts of it, is the kind of thing you find compelling, let me know in the comments which population's DNA history you'd want explored next. What the genetic record suggests, cautiously and without false certainty, is that the Maya were never a single people moving in a straight line through time. They were and are the result of multiple lineages, multiple migrations, and at least one population whose presence we can only detect as an absence, a statistical shadow in the data of those who came later. The old map placed them neatly. One origin, one path, one destination. The genome suggests something far less tidy and far more human, a story of people arriving, mixing, vanishing, and being remembered only in the DNA of those who replaced them. The pyramids still stand. The language still echoes in millions of living speakers, but beneath all of it in the genetic code itself. Eldier, there is a deeper history, still only partially read, a reminder that even the most studied civilizations on Earth can still hold chapters we haven't found yet. The map, it turns out, was never finished. It was only ever a sketch of what we'd managed to see so far.